Now we're going to do a bona fide example. We're given a curve f of x equals 1 plus x squared, and we're limiting the domain from x equals 0 to x equals 1. And we're going to actually find the upper and lower estimates for the area under the curve. The upper will be a little bit extra and the lower will be a little bit less than the actual area under the curve. Okay, step 1. Let the initial x value, x sub 0, equal the left endpoint in the restraint on the domain 0, and x final equals 1. Let the width of each of the rectangles be constants, be the same value. We'll call it w sub I for the ith width, and we'll use the formula w sub I equals x final minus x initial over the quantity of rectangles. We were told to use 3 rectangles in this problem. We usually call that quantity n. N is a number of rectangles. So the width w sub I for each of the 3 rectangles is going to be equal to the last x value 1 minus the first x value 0 divided by 3. So w sub I, the width, is equal to 1/3. Step 2, we're going to do a sketch of each the lower and the upper estimation. And remember, on the lower estimation, that's where we use the left endpoint of the rectangle actually living on the curve f of x, and for the upper estimation we use the right endpoint living on the curve. So for the pictures, you can see on the left we're doing our left endpoints. I'll just rush along a little bit. Whoops, that didn't rush it along. There you go. I'll stop it there so we can discuss it and you can copy it. Okay, so on the left we see left endpoints, and that's an underestimation of the area under the curve, and we divided the bottom between x equals 0 and x equal 1 into 3 equal rectangular widths of w sub I equals 1/3. That means w sub 1 is 1/3, w sub 2 is 1/3, and w sub 3 is 1/3, the width of the first, second, and third rectangle. And the same thing on the right. The only difference with the picture on the right is now we have right endpoints of each rectangle actually living on the curve f of x, and that causes our rectangles to be above the curve and gives us an overestimation of the area under the curve. Okay, so step 3, after our sketch, we're going to do a sum. First we'll sum up the 3 rectangles on the underestimation, the lower estimate, and that's going to be less than the actual area under the curve, which will be less than the upper estimation, the sum of the 3 rectangles on the right. And now we want to see really closely. We're going to do a close-up here of one of the rectangles and the curve. You see what's happening is the left endpoint is touching the curve. So it's actually the left side L and the width W that we're interested in. While for the other situation, the rectangle is touching the curve on the right endpoint. So the L value is measured on the right side where it touches the endpoint with a W on the bottom. So remember that. That's the difference between taking the area for the left endpoint and the right endpoint. Okay, so the area of the first is L sub 1 times W sub 1 plus L sub 2 times W sub 2 plus L sub 3 times W sub 3. That's going to be less than the area under the curve, which is less than L sub 1 times W sub 1 for the right side plus the area of the second and the area of the third. Okay, what is the left side? Back to the next line. That's the function evaluated at x equals 0 times the width 1/3 plus the function evaluated at 1/3 times the width 1/3 plus the function evaluated at 2/3 times the width 1/3. And we have something a little different happening on the left. Here we're using the left side for the length, so it's the function evaluated at 1/3 for the first length times the width, and then the function evaluated at 2/3, and then the function evaluated at 1. So that's the difference. We use different sides for the L value, and the L value is the actual function evaluated at that x value. Okay, so now let's actually evaluate the function, and we're using the given curve f of x equals 1 plus x squared, and that's going to give us, let's see, f of 0 evaluated by putting x equals 0 into the function at the very top, and we get 1 times the width 1/3. And then the function evaluated at 1/3 gave us 10/9 times the width 1/3, plus the function evaluated at 2/3 gives us 13/9 times the width 1/3. That's less than the actual area under the curve, which is less than function evaluated at 1/3 is 10/9 times 1/3, plus the function evaluated at 2/3 is 13/9 times 1/3, plus the function evaluated at 1 is 2 times 1/3. So we're simplifying that. We get 9/27 plus 10/27 plus 13/27. That's with the common denominator. That's less than A is less than 10/27 plus 13/27 plus 18/27. So pull out your calculator. You get 1.19 square units for the area for the left endpoints, 1.52 square units for the area with the right endpoints, and those appear on both sides of the actual area. The actual area is wedged someplace in between.